Hello everyone. Today I will be discussing the topic of CTE. CTE stands for chronic traumatic encephalopathy. It can be described as a neurodegenerative disease that involves progressive damage to brain cells. In terms of research and discovery, CTE is a relatively new disease. In fact, much of what we know about CTE can be attributed to Dr. Anne McKee, director of the VA BIO CLF Brain Bank, established in 2008. This foundation combined efforts from the U.S. Department of Veteran Affairs, Boston University, and the Concussion Legacy Foundation to become the first repository in the world dedicated solely to the study of CTE. Roughly 70% of all known global CTE cases are housed by the Brain Bank. Dr. McKee can also be credited with discovering the first cases of CTE in athletes who play soccer, rugby, baseball, hockey, and high school to college level football. Now that we have a little background on our topic, let's explore what causes it. It has been commonly accepted that CTE is caused by repetitive mild to severe blows to the head, including traumatic brain injuries that cause symptoms like those seen in post-concussion syndrome. However, it is more widely believed that the main driving force behind CTE is actually subconcussive impacts that cause little to no apparent symptoms. A subconcussive hit can be described as a blow to the head below the threshold of a concussion. While there is damage to neurons, it is not severe enough to show immediate outward symptoms like with a concussion. This is why someone who has never been diagnosed with a concussion is still capable of being diagnosed with CTE. Unlike other neurodegenerative diseases, the progression of CTE is fueled by repetitive subconcussive impacts that cause a buildup of tau protein in the brain. This protein forms clumps and spreads to other areas of the brain. Also unique to CTE, tau clumps tend to collect around blood vessels and the cortical sulci. The cell body is responsible for creating messages that are sent along the axon to the axon terminal that convey messages to the appropriate cells in other parts of the body. The weakest part of the neuron is the axon, which is made up of many microtubules. These microtubules provide stability to the axon, which is reinforced by tau proteins. In healthy neurons, tau proteins are good, yet they are the opposite in diseased ones. Microtubules are vulnerable to damage by smaller impacts like subconcussive hits. Even though the axon might remain intact, the microtubules inside begin to fall apart. Once deterioration begins, tau proteins are released and start accumulating. Among the many contributions by Dr. McKee is the proposed method of classification of CTE. Stage 1 is characterized by isolated tau clumps in the cerebral cortex. Stage 2 shows multiple tau clumps in the cortical sulci. Stage 3 occurs when tau clumps begin to enlarge and blend together and appear more diffuse throughout the ridges of the brain. Stage 3 is also characterized by tau accumulation in the hippocampus and amygdala. Stage 4 involves dark, dense tau accumulation covering the cerebral cortex and almost all other brain regions, including the spinal cord. With CTE, symptoms can be quite variable and don't usually appear until many years after the onset of head trauma. Early symptoms can appear as early as late 20s to 30s, but usually symptoms affecting mood and behavior are seen in late 40s to 50s. Some behavioral symptoms include aggression, impulsivity, rage, and agitation. Mood and emotion symptoms include anxiety, depression, paranoia, and suicidal thoughts. Cognitive symptoms usually appear after changes in mood and behavior. These symptoms might include impaired judgment, confusion, memory loss, and eventually progressive dementia with trouble walking and speaking in some cases. Since tau accumulation and spread is extremely slow, it takes time for the brain tissue to become infected enough to actually cause substantial dysfunction. This is why symptoms may worsen with time even without new head trauma. A person can be stable for years before getting worse. There is currently only one way to accurately diagnose CTE, post-mortem through analysis of brain tissue. After death, the brain is soaked in a special chemical that binds to tau, making it visible during tissue analysis. This is a very lengthy process and can take up to several months to complete. Currently, there is no cure for CTE, For those showing signs of CTE, symptom management is used to target problem areas and alleviate stressors appropriately. This might include seeing a therapist, acupuncture, massage therapy, memory training exercises, or medication. Right now, more focus is being placed on prevention by limiting risk factors like delaying the age of first subconcussive impact or eliminating contact when unnecessary in high-contact sports like football.